All right, so today's video is going to be just a little review of some properties of exponents that you have looked at in past years that will probably need a little refresher on. So if you want to go through this on your own and see what you remember and fill in everything in that you know, please do. If you want to kind of follow along with me, you can. But either way, I would make sure you at least check your work to make sure the properties that you think you remember are accurate. Um, so I'm going to get right into it. You've heard me say it a lot this year. If you ever forget something more general, so if you're working on a question with a lot of exponents, a lot of simplifying, go back to something basic that you know for sure. So on the left-hand side, I kind of have our specific basic rules, and then we're going to apply them to some more general rules. So this is the worksheet I passed out in class. This is not in your note packet. It's also attached onto this homework assignment. You will have a Google form that goes with it afterwards. So jump right into it. 5 to the 0 power. I don't know why I wrote 5 again. 5 to the 0 power is 1. Anything to the 0 power is 1. So x, y, z, the quantity to the 0 power is 1. 7 million to the 0 power is 1. So that's our first property. 5 to the first power is basically just saying 1, 5 is 5. So a to the first power is just a. We know what 5 to the third is, but I'm kind of showing this for a reason. 5 to the third is 5 times 5 times 5, which we could then type into our calculator. That's probably one we know is 125. So a to the third power is really just a times a times a. So the reason I showed that is to help us remember this rule here. So a lot of times we'll see a rule like that and we're like, okay, do I add the exponents? Do I multiply them? What's the rule here? So 5 to the third times 5 to the second is really just 5 times 5 times 5 times 5 times 5. So what that is 5 fives. So our rule of thumb here, when you're multiplying same base exponents, we add the powers. So 5 and 5, they have the same base. We add those exponents. So a to the m times a to the n is a to the m plus n power. We're adding those exponents as long as the bases are the same. 5 to the fourth over 5 to the second. What that really is 5 times 5 times 5 over 5 times 5. We think back to the rules we've talked about all year as far as dividing things out. So what that really comes out to is 5 to the second. So when we are dividing those same base exponents, we subtract their powers. All right, we could also do some work. We could also treat this like a negative exponent, which we'll talk about a little bit on the next page. So anyway, a to the m divided by a to the n is the same thing as a to the m minus n. So we subtract those exponents. 5 times 3 squared. Yeah, I know we could distribute and just call it 15 squared. That's not really what I'm getting at on this one. We can basically break those parentheses by just, it's kind of distributing, but I guess it's more applying that second power to both of the terms within it. So 5 squared times 3 squared, a times b to the n is the same thing as a to the n times b to the n. And then same thing happens when you're dividing. 5 divided by 3 squared is the same thing as 5 squared over 3 squared. So these probably were fairly familiar to you. When we start looking at fractional exponents and negative exponents, that's where you may need to do a little more reviewing. So hopefully that's a good start. Go ahead and flip to the next page when you're ready. As always, rewind, pause if I'm going too quickly. Now a power to a power. So what this really is 5 to the third squared. 5 to the third times itself, right? So 5 to the third times itself is really just 5 times 5 times 5 times another 5 times 5 times 5, giving us 6 fives. So when we have a power raised to a power like this, we multiply the exponents, okay? So 5 to the third squared is 5 to the sixth. So a to the m to the nth power is a to the m times n. All right, negative exponents. 5 to the negative 1 power. What might help is if you visualize this as if it's 5 over 1 to the negative first power. So 5 to the negative first power is the same thing as 1 over 5 to the positive first power. So when you see a negative exponent, you think about flipping that term into the other side of your fraction. So you're thinking about the reciprocal. So a to the negative first is the same thing as 1 over a to the positive first. And of course, I don't really have to write that positive 1 there. 5 to the negative 3. 1 over 5 to the third. So that's kind of what I was mentioning before when I showed you the 5 to the 4th over 5 squared. I could actually rewrite this. If I wanted to think of it as a negative exponent, I could rewrite this as 5 to the 4th. And I could bring that 2, if I really wanted to do it this way, I could bring that second power, flip it into my numerator, and call it 5 to the negative 2. And now you can see that's another reason adding the exponent would give me 5 squared. So this is that just hypothetical example from the first page. But in general, negative exponent, you take that term, you flip it to the other side of your fraction. So kind of what I just showed you, 1 over 5 to the negative third, it can work the other way around. 1 over 5 to the negative third becomes 5 to the positive third over 1. So 1 over a to the negative m power, we can take that negative exponent, flip it up into the numerator, and then it becomes positive m. 5 to the 1/2. That's our root function. So it's basically the square root of 5. You don't really have to write that because that square is implied, but a to the 1 over m is the mth root of a. So whatever that could be a 5, 1 over 5 would be the 5th root of a. 1 over 7 would be the 7th root of a. Then we can combine them. We can make them negative. We could do all sorts of things. Well, maybe I'll combine them all. Maybe I'll change this to a negative. So 5 to the, you know what, forget that. Let's just do a couple at a time. 5 to the 2/3 power. We can apply both of these these integers, these constants, separately. So 5 squared over 3. So it's basically we're saying we're taking 5 squared and we're taking the cubed root of that term. So 5 to the 2/3 power is the cubed root of 5 squared. So really just generally speaking, a to the m over n power is the nth root of a to the m power. All right, so I hope that all seems somewhat familiar. Let's jump into our note packet. I just want to walk through one example. So we're on page something of your note packet. We're on page 9 of your note packet. Page 9 of your note packet. I want to look at number 6. So same thing, if you want to try this on your own for a minute, you can. I will walk you through it. We are going to get to this whole page, so you don't have to feel like you have to do them. If you want to look at them, you can. But I'm going to, you know what, let's start with number 3. Just a little bit quicker, a little more basic, so we can get this video done, and then we'll do more practice next time. But if I look at my numerator, I'm just going to kind of break this out one term at a time. So 6a to the 1/2 power is 6 to the 1/2 times a to the 1/2. This AB, quantity under the square root, actually same thing. A to the 1/2, b to the 1/2. All over, and then here we have a squared b to the 3/2 power. So if I just want to clean this up a little bit, I can take these two a to the 1/2 here. A to the 1/2 times a to the 1/2. We're going to add those powers together. So basically I have 2 halves of an a. I'm going to combine that into an a to the 1st. So a to the 1/2 times a to the 1/2 is a to the 1st power. So that makes that a little bit easier to look at. And now let's see what we have left. I have my 6 to the 1/2, aka the square root of 6. I have an a to the first in the numerator. I have an a squared in the denominator. So two ways to think about it. You can think about it like subtraction. So a to the 1 minus a to the 2. So 1 minus 2 would be a to the negative first power. Really probably a more straightforward way to think about it is I have one a in my numerator. I have two of these a's in my denominator. I have a times a. So one of those a's up here divides out with one of the a's down here. And we're left with this a to the first power in my denominator. All right, so really, like I said, this a squared is really just a times a. One of those a's divides out with my a in the numerator. And then same thing, I have b to the 1/2 in the numerator. I have b to the 3/2 in the denominator. So I basically have half of b up here. I have, 1.5 b's down here, or 3/2 b's. So where are there more b's left over, and how many more are there? 3/2, take away that 1/2, leaves me 2/2, which is just b to the first power. So there's my simplification of this first kind of exponential simplification that we're going to try a bunch out. So, number 6 is a little more challenging. If you want to take a look at it, you certainly don't have to. We're going to spend some time looking at these in class, but that's what I'm expecting you to come into class remembering and reviewing and refreshing, and let me know if you have any questions. All right, guys, I'll see you in class. Bye.